In the ancient Babylonian myth, Epic of Gilgamesh, Gilgamesh was a powerful figure whose constant companion in battle was stricken ill. The tragic loss of Enkidu inspired in Gilgamesh a quest to escape death by obtaining godly immortality. Against the will of the gods, he learned of a magical plant and valiantly fought to discover it. Now, if there really was such a plant, would we humans be able to obtain its gift? Actually, we may be closer to this than you may think. With the discovery of a naturally occurring enzyme, telomerase, scientists are paving a way to lengthen the tips of our DNA, and in turn, lengthen the human life expectancy, and potentially open the door to cure a number of diseases. The Aging Cell of April 14, 2011's groundbreaking study reports that the telomerase activator increases the health span of adult mice without increasing cancer incidence. Further, BBC News on January 9, 2012 explains that when telomerase is turned on in mice, it reversed the aging process. To fully appreciate the enormous potential of telomerase, we will first understand what telomeres are. Second, examine how telomerase is currently being utilized. And finally, reveal the future applications and implications of this breakthrough. To understand what this discovery means, let's first have a quick biology lesson on cell reproduction, and second, reveal the telomerase breakthrough. So, let's go back to school. Every cell in the human body contains our DNA, long molecule structure similarly as twisted railroad, and our genes resemble the wooden ties of that railroad. Now, located at the tip of each DNA strand is a telomere, a protective cap. Oncology Times in May 7, 2011 illustrates that just like aglets on the ends of shoelaces, the telomere prevents our DNA from being damaged. Dr. Michael West is the founder of Geron Corporation, the first biotechnology company to focus on human aging. In his 2003 book, The Immortal Cell, he compares DNA replication to a boxcar running along our twisted train tracks, and the men up front are duplicating the wooden ties, or our genes, as they go. Each time a cell divides, the DNA information within a cell is copied. Once all of our genetic makeup is copied, the old cell splits into new cells. However, when the boxcar gets to the ends of the tracks, it has to stop. Telomeres don't get weaker over time. Rather, they just get shorter with each cell division. As their size reduces, their ability to perform their main function, protecting our DNA, also decreases. Thus, a cell will die when it physically can't divide anymore. Over time, when enough of our cells stop reproducing, we begin to age. Until, as Life Extension magazine of April 2011 puts it, you and your cells eventually die. Fortunately, an enzyme called telomerase can suppress telomere shortening. Telomerase was first discovered in 1985 and won the 2009 Nobel Prize in Medicine. In 2010, a team at Harvard Medical School began the research of genetically altering mice. First, they deactivated the gene, and the mice aged prematurely. Next, they altered another set of mice the same way with the same results. However, at 6 months of age, the team switched the telomerase gene back on. Surprising results showed that instead of dying, they started behaving like normal 6-month-old mice. The study revealed that if we can turn on or off the gene that controls telomere length, then we can rejuvenate cells and lifespans. By acknowledging telomeres and this discovery, we will now examine how telomerase is currently being utilized by first preventing aging and second fighting cancer. To begin, the ancient astragalus herb has been used for 1,000 years in Chinese medicine to strengthen the immune system and heal injuries. And now, a California biotech company, Geron, plans to use it to prevent aging. When consumed, Geron's TA65 capsules, or what they call the telomerase activator, attaches to the short ends of our DNA. The enzyme has a pre-designed template which guides our DNA to lengthen itself, resulting in a longer tip, or telomere. The TA Science's website on February 3, 2012 demonstrates we measure your telomeres before, during, and after treatment to show changes in telomere length, resulting in significant reversal effects such as improved skin condition, cardiovascular health, and The TA Science's website demonstrates we measure telomeres before, during, and after treatment to show changes in telomere length, resulting in significant age reversal effects such as increased bone density, skin condition, and improved cardiovascular and psychological health. Second, scientists believe telomerase is the future of fighting cancer. How? The January 2011 Royal Society of Biological Sciences reports that if our normal DNA telomeres fail to function as they should, chromosomal aberrations can occur. In other words, cancer is caused by misbehaving telomeres. But that's not all. Science Daily on October 22, 2011, explains that unlike our normal DNA telomeres, cancer cells keep rebuilding their short telomeres, preventing them from dying and thus creating cancerous tumors. So, the March 24th Medical News Today explains that scientists hope to deactivate the gene in cancer cells, so they eventually die like our normal cells do. And at the same time, activate the telomerase gene in our normal cells to extend their life. Also, we can put the cart before the horse and use telomerase treatment to detect cancer cells before a visible tumor forms, or simply create natural cancer fighters, antibodies, and vaccines to help delay cancer instead of curing it. By acknowledging how telomerase is currently being utilized, we can finally reveal the future applications and implications of this breakthrough. Let's start with the future applications. Telomere biology could be applied to cloning. The concept of cloning is simple. Take out an egg cell's DNA and replace it with an adult cell's DNA. But what if we took an old cell with short telomeres, returned it to the egg to reset telomere length? We could possibly make embryonic stem cells without having to use controversial embryos. Therapeutic cloning allows us to reverse the aging process as a means to cure diseases. BBC News on January 26, 2011 explains that the focus is not on extending life, but on extending good health. And telomerase extensions can do just that. The ripple effect could touch many age-related diseases like osteoarthritis, macular degeneration, type 2 diabetes, and heart disease, Parkinson's. Let's not forget about inflammatory diseases, which are caused by the degeneration of connective tissue, like hepatitis, dermatitis, asthma, and Parkinson's, all because our cells wouldn't age. Our final application was published this January in the Proceedings of the National Academy of Sciences. A study done on zebra finches led University of Glasgow researchers to the breakthrough discovery. The finches with the longest telomeres live the longest. Now, before you rush out to get your telomeres stretched, Science Now in January 2012 cautions scientists must continue this research. Whatever our telomeres may save, human lifespans also have to contend with additional factors like diet, stress, and the environment. Second, the implications are beyond human imagination, but come with environmental, financial, and ethical issues that need to be addressed. The TA Sciences website explains that the cost of this technology can fall between $4,000 and $9,000 per month because of limited resources. While scientists expect this price to somewhat tumble, the high cost associated with telomerase treatment creates a class divide, where the affluent could potentially live 20 years longer, leaving the lower classes at yet another health disadvantage. Nonetheless, as we extend life, we are also extending the amount of resources a human being uses on this planet. Can Earth support its inhabitants living longer? The U.S. Census Bureau on October 21, 2011, declared the world population to be 7 billion people, and of them, 1.4 billion live in extreme poverty. Our capacity on this planet may already be stretched to its limits. And finally, with the biomolecular revolution on its way, we can turn engineered cells into engineered people. One can only imagine that one day we can simply shuffle our genes to enhance human traits. However, is it ethical to be messing with our DNA and our cells at such a level to fight death in nature? These questions, along with the financial and environmental issues, need to be addressed before moving forward with this technology. We first understood what telomeres are. Second, examined how telomerase is currently being utilized. And finally, reveal the future of this incredible breakthrough. Loving one another is among the most valued human characteristics. The myth of Gilgamesh is a story of a battle of love over death. And like Gilgamesh, our quest will always be to save the lives of those we love.